So, in this series, we will talk about the clash as a risk throughout the project lifecycle. Up to this point, we have established that clashes are not really just the geometry problems, they are the risk signals. And if clashes are treated as a risk signals, then the next question becomes what happens to that risk? Because risk just doesn't disappear simply because we tend to not look at it, right? And one of the biggest misconception in our industry is treating clashes as an isolated event. A clashes that has been discovered during the design stage just doesn't stay at the design stage. It moves from the design to the construction to the commissioning to the operation and to the maintenance issue. And as we have discussed before, that the geometry may change and this risk will remains as it is. And when we identify these clashes, we are not simply identifying a conflict between two objects, we are actually identifying the potential consequences uh, to where this clash is. And the real question is like, what happen if we do nothing about it? Because that answers changes as the project moves throughout the life cycle, and that may also lead to the next discussion, which is one of the most important in clash management, is that the risk change the values over time. And within this pyramid, we are seeing two different points here. There is one which is for the various clashes related risk at the different design stages. And on the second, we are seeing the dynamics of those clashes risk. Mm. As as we said that a clashes during the design may require a discussion, right? There will be a change into the model revision. There may be some decision that needs to happen throughout the design, right? If the exact same clash has been discovered during the construction, that potentially has a bigger impact because during the design stage, when we are talking about identifying a potential issue, the fix to that clash may require a couple of hours or maybe a couple of minutes. Whereas if that is ignored during the design stage and it passes through the construction, which means that that will require a lot of rework. There may be material that has already been ordered, so there may be a wastage of the material, remobilization of the trade, because there might be a trade that has came to the site for the installation, but due to those conditions, they may have to schedule, they may have to plan for another schedule, right? And it all brings back to this additional cost. So the issue hasn't changed, it's only the timing that has changed, and with this change there are consequences. And I think this is where the model based or pin based coordination creates a lot of value, not just because we are looking at this at a model, but it also because it has the that level of visibility, right? And then you can tag those issues based on the different risks that it has. If we start collecting the class data, we can actually learn from it. And then there is a huge difference between these two different things, because once you start running these clashes over a period of time, let's say on a weekly basis, you run the clash detection, that execution of those clashes can actually give you some pattern, and that pattern can be used to dictate the stories of those clashes, right? Imagine if I tell you that there are project that has 2000 clashes, right? Then that number itself doesn't tell you almost nothing, right? Because most of them may occur with different rates, with different at different levels, at different zones, right? There is no such clarity if I just tell you that there are 2000 clashes that are there within the model, right? But once we start differentiating that if those clashes are in a mechanical room or at a specific shaft or at a specific plant room, we can then understand the behavior of those clashes, right? And that understanding of the location can help you to communicate the issues properly. There may be ways where you can directly assign the ownership of those issues. And if there are any decisions that are delaying because of that, then we can look at observing those different systems that can help us to understand this clashes based on more dense area. And this is where the clash management becomes more bigger than your just regular BIM coordination or a model coordination meeting, because every clashes it connects to something, right? That something could be your cost, your schedule, the safety, constructability, right? The clash itself is rarely the biggest issue. The consequences is, and that changes how we think about coordination. And to be honest, the objective is not just simply removing a geometry conflict. The objective is to reducing the risk, right? Improving the decision making process, where a clash affecting the maintenance axis may create more life cycle costs than a hard clash that is discovered during a design stage. And one of the biggest challenge in our industry is the fragment understanding, right? Because you may have an architect who may understand the architecture very well, right? The engineers may be the same. They may understand the engineering very well, and that you may have a contractor that they may understand only the construction very well. Similarly to that, then you may have operators who understands the operations very well. But projects can only succeed when the perspective of these different stakeholders connect together, because many problems that don't occur because of the lack of visibility. It happens because an architect, when they are designing this, they are not seeing the impact on MEP, and similarly vice versa to those different stakeholders. And this is where the knowledge flows effectively between the disciplines, because coordination is ultimately a human activity supported by technology, right? It's nothing to do with terms of the software. And oftentimes I have experienced this in the past where people are so good with the software, but they have a very less understanding in terms of how the constructions happen and how the information needs to flow at the different design stages, right? So this is where I think we should understand how it actually works.